Let's go ahead and continue our unit on thermochemistry, and our goal today is to calculate heat. So, as a quick recap, heat is the transfer of thermal energy between two objects at different temperatures. We said that heat always flows from a hot object to a cold object, and that heat will continue to flow until the objects reach thermal equilibrium, or that they're both at the same temperature. Now, we use the word endothermic to describe heat flowing into a system, and exothermic to describe heat exiting a system. Now, one thing we didn't go over are the units for energy. Historically, we've used the unit calories, and we still see this in our foods, though that's slightly different than this calorie. A little c calorie is defined as the amount of energy required to raise the temperature of 1 gram of water by 1 degree Celsius. The problem with this unit is that it changes depending on the pressure outside, for example. The SI unit that we use now is something that we call the joule, and it's defined as the amount of energy used when 1 Newton of force moves an object 1 meter, and that's standard. So to go between these, we can actually say that 1 calorie is equal to 4.18 joules approximately, and we'll work with this more later on. It's just kind of background. Now, because heat leads to temperature changes, we're going to measure the amount of heat using temperature changes. And we got to consider that temperature changes really depend on three factors. The first one, of course, is the amount of heat that I put into something. For example, heating a water sample with a table lamp versus heating on a stove. The stovetop is going to be putting out more heat, and it's going to be able to heat up the water to a higher temperature. Another factor is the amount of stuff that is being heated, or the mass of the sample being heated. If I take a small pan and I heat it versus a large pan and I heat it, and I apply the same amount of heat, the bigger pan is going to change its temperature less because there's more stuff to heat with the same amount of energy. And the last thing that it goes into how much the temperature will change is the actual material. And every material has what we call the different specific heat capacity, or the amount of energy it takes to change the temperature of that material by 1 degree Celsius. So for example, water takes 4.18 joules for every gram. But something like ethanol will take less energy to change its temperature. It takes about half as much, 2.3. So if I heat ethanol and water on a stove, the water is going to take longer to boil. The ethanol will reach a higher temperature faster. And we can kind of also do this with other materials besides liquids. We know that a wooden spoon, for example, heats up a lot slower than a metal spoon. And we can quantify these in lots of different tables. And through these tables, we can talk about the way that different materials heat up. The bigger the specific heat, the more energy it's going to take to change the temperature of that material. Now, to calculate heat, we actually just got to use a simple equation, and it's Q is equal to M times C times delta T, where Q represents the amount of heat, M is the mass of the substance being heated, C is the specific heat, and delta T is the change in temperature, which we might have to calculate, and that's just going to be whatever the final temperature is minus the initial temperature. So here's a quick example. A flask containing 800 grams of water is heated, and the temperature of the water increases from 21 degrees Celsius to 85 degrees Celsius. If the specific heat of water is 4.18 joules per gram per degree Celsius, how much heat did the water absorb? Same process as always. First, we annotate, we underline our givens and circle our question. And then we know the equation, so really we're just going to figure out what numbers I know, plug them in, and solve. And here it's just 800 grams times 4.18 joules per gram per degree Celsius. The change in temperature is 85 minus 21, which is 64, and we get about 214,000 joules, or 2.14 times 10 to the minus 3 joules.